Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating GitHub project, Bzip3, a claimed better and stronger spiritual successor to the venerable Bzip2 compression algorithm. Pretty exciting stuff, right?
Absolutely. I've always been intrigued by compression algorithms. What makes Bzip3 so special? Is it just faster, or are there more fundamental improvements?
Well, it's not just about speed, although that's a significant part of it. The core innovation lies in its entropy coding. Bzip3 uses a novel order -0 context mixing entropy coder, which basically means it's better at predicting the next bit in a data stream. This leads to higher compression ratios.
ORDER zero context mixing. That sounds pretty technical. Can you break that down a bit more for our listeners?
Sure. Think of it like this. Traditional methods look at surrounding data to predict the next bit. ORDER0 means it doesn't rely on that context as much, focusing on statistical properties across the entire dataset. It's a different approach, and apparently, a very effective one.
I see. So it's a more global approach to prediction. Interesting. The GitHub page mentions a fast Burrows-Wheeler transform using suffix arrays. What's the significance of that?
The Burrows-Wheeler transform, BWT, is a crucial step in many compression algorithms. It rearranges the data to make it more compressible. BZip3's implementation uses suffix arrays to speed up this process significantly. It's a clever optimization that contributes to the overall performance boost.
So it's a faster and more efficient BWT, combined with this innovative entropy coding. That's a powerful combination. The benchmark results on the GitHub page are pretty impressive, especially the comparison with BZip2 and XZ.
They are indeed impressive, but we need to be cautious. The benchmarks are based on a specific dataset, a large collection of parallel source code. While this is a relevant test case, it might not be representative of all data types. We should always consider the context of the benchmark.
That's a fair point. Generalizing benchmark results can be misleading. What about the licensing? The GitHub page mentions several different licenses for different components.
Right. The core Bzip3 code is under the LGPL 3.0 license, but some components, like the Burrows-Wheeler transform library, have different licenses. It's important to check the details if you plan to use it in a commercial project. It's a bit of a licensing patchwork, you know?
Definitely something to keep in mind. Overall, though, Bzip3 seems like a significant advancement in compression technology. The combination of improved algorithms and optimized implementations is compelling.
Absolutely. It's a project worth keeping an eye on. The high compression ratios and speed improvements, especially on x64 Linux with Clang 13, are very promising. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Bzip3. Have a great day.
Bye-bye.